Hello friends, today we start with the next chapter in maths, that is circles for standard 8th ICSE students. Now it's a very simple chapter, okay. There is a very small exercise over there, and there's only certain kind of, you can say, the terms which are going to be important in case of circles. So let us go one by one to the different terms, different parts, different kind of things what we can do inside the circle. What are the things? So let's see one by one the different parts of the circle. So firstly, we understand that the circle is a closed figure such that it is equidistant from a given point. Okay, a circle is a set of all those points, say P, in a plane of which it at a constant distance from a fixed point. That means if this particular point is P and this particular point is O, this P is traveling in such a way that it is always at a constant distance from here. So this is going to be such that this is going to be the same. अगर ये distance x है तो ये भी x होगा, ये भी x हो गया, यहाँ से यहाँ का distance भी x है, यहाँ से यहाँ का distance भी x है. So accordingly you will find that this point P is traveling in such a way that it is always equidistant from a given fixed point. Okay, if this point P is moving around this point O in such that the distance between O and P is always going to be remaining the same, then what is going to be formed is a circle. So circle is a closed figure which is having its points always equidistant from a given fixed point. And it is seen that this particular, so we'll just release this part, and this particular distance between the center, so this O is called as the center. The center O, so O is center of circle. The distance between the center of the circle to P, so this particular distance from here to here, the x what we have written over here, is the radius of the circle. So the distance OP is equal to radius of circle. Okay, so the fixed distance between the fixed point and that moving point P, so that distance over there between the points is called as the radius, which is always positive. It can never be negative. So the radius is always positive. So we can see over here that OP is the radius. Even if I take a point Q over here, then OQ is also the radius. So OP is the radius, OQ is the radius. So all these are the radius of the circle. Now, when you have a point, okay, now suppose you have got a point, and if the point is such that, suppose I take a point A over here, and if it so happens that the distance OA, if OA is less than the radius, then the point A lies in the interior of the circle. That means it is lying in this particular interior of the circle because the value of OA is less than the radius. If the value of OA is less than the radius, it lies in the interior of the radius. If the value A is over here, and if this value over here is greater than the radius, so if OA is greater than the radius, then A lies in the exterior of the circle. So this is the exterior part, this is the outside part. The outside part over here is the exterior part of the circle. But if OA is equal to radius, so if it is equal to the radius, that means if it is on this particular point over here, that this is also the radius, then it is called as a A lies on the circle, on the circumference of the circle. So that's why the circle is divided, or a circle divides the region into two parts. One is the interior of the circle, where the distance between a point and the center of the circle is less than the radius. And the other one is the outside, that is the exterior part, where the radius, where the point is at a distance more than the radius. Because the third part, that is the circle itself, is the one wherein all the points on that circle are equidistant, that is equal to the radius. So that's why the interior of the circle and the exterior of the circle is named that way. And if the point is exactly at the radius, that is, it is equal to the radius, then it is the circular region. So that's why the set of all the points of the plane which either lie on the circle, that is the circumference of the circle. So that is the circumference of the circle, where A is equal to the radius. So accordingly, this area over here, that is the circumference and the interior, the circumference and the interior combined together, we can be said to be as a circular region. What is a circular region? The circular region will be all the points which are within the circle or on the circle, or which are the one which lie either on the circle or inside the circle, form the circular region. Okay, so this is about the circular region and circular part. Now let's see some additions to the circle, some lines which are going to pass through the circle. What are they called? So let's see the first thing. So first is, if I have got a circle and if I got a segment which is drawn joining 2 points on the circle, okay, this is a segment drawn which is joining 2 points on the circumference of the circle, then such a particular segment is segment AB is called the chord. Okay, this is the chord of the circle. So chord of the circle is the line segment joining any 2 points on the circumference of the circle. Now, if this chord is such that it passes through the center, means if the chord is such that it passes through the center, then this chord becomes the diameter. Okay, so a chord which passes through the center of the circle is called the diameter. Diameter is the longest chord. And what is the length of that? The length of the diameter is equal to 2 times the radius. Why? Because from here to here is the radius and here to here is the radius. So the diameter is equal to 2r. Okay. So diameter is equal to twice the radius, because diameter is the longest chord which passes through the center of the circle. So from here to here is one radius, from here to here is another radius, and there cannot be any particular line which can be drawn, or a chord which can be drawn which will be greater than the diameter. So diameter is the longest chord of the circle. What else? And it will be value will be equal to twice the radius. Now if this particular chord के बदले अगर एक line होता, if there is a line which is passing through the circle or cutting the circle at 2 points, then this line is called as a secant. Okay, so a segment is a chord whereas a line, so segment, this is a line segment. Whereas a line AB will be a secant. Okay, this is not a segment, it is a line, so it is extended on both sides, so that's why it's a line. So line segment is a chord, whereas a line is a secant. We see one more thing over here, and that is called as a tangent. Now if I draw, okay, I'll just erase this part. I'll draw it here. This is the chord. Now if there is a line which is touching the circle at only one point, that means if it is a line which is touching the circle at only one point over here, then such a line is called as a tangent. Okay, so this line we can say PT. So PT over here is a tangent. So tangent is a line drawn to a circle such that the intersection point between the circle and the line is only one single point. Okay, or the line which touches the circle at only one point is called as a tangent. Now tangent के दो important properties है जो तुम लोग को learn करके रखने हैं. There are two important properties which you need to learn about the tangents. The first property of the tangent is that if I draw a radius from here to here, if this radius is drawn, it will be seen that if this is O and this is OP will be perpendicular to PT. That means this is going to be 90 degrees. That means always tangent. So first property is tangent is perpendicular to radius. Of course at the point of intersection to radius. Okay, tangent is perpendicular to the radius. Another important thing is that if I have got two tangents drawn from a point outside the circle, like for example, I have got a point outside the circle over here like this. So one tangent is this one. Another tangent, let's say if it is going to be this one, I just made it slightly inside. Okay. अगर मैंने दूसरा यहाँ पे किया तो this one over here. So suppose it is meeting at point A and this is meeting at point B and this is point, let's say Q. Then it will be seen that if two tangents are drawn from a point outside the circle, again I'm repeating, if two tangents are drawn from a point outside the circle, then their lengths will be equal. That means PQ will be equal to PA. I just show you another figure. If I got the circle and I got a point over here which is point A, if this is one tangent over here and this is another tangent over here, then if this is A and this is B, then PA will be equal to PB. So PA is equals to PB. So what is the second point? The second point over here is tangent from point, tangents from point outside the circle are equal. Okay, so we know that tangents, if I have given a figure like this, I automatically know that PA will be equal to PB. I don't even have to think, I don't just have to say that PA will be equal to PB. Also, the first point over here was, if there is an O point over here, then OA is perpendicular to PA and OB is perpendicular to PB. Got it? So this way you can see that you are going to be having PA is equal to PB and this two, angle A and angle B, are 90 degrees each. So these are the properties of the tangent. So tangent will always be perpendicular. The first thing is tangent is always perpendicular to the radius. And secondly is that only one tangent can be drawn from a point on the circle. If I want to draw a tangent from a point on the circle, it will be only one possible. But if I point outside the circle, then I am able to draw two tangents and both these tangents are equal. Okay. जैसे यहाँ पे I cannot draw another tangent at point P. it's not possible for me to have another tangent at point P, because I cannot draw two different perpendiculars at the same point, right? So there's only one line OP which is perpendicular to this line. So that's why only one tangent can be drawn at a point on the circle. But outside the circle, say I can draw two tangents, one like this and one like this, and they always are equal in size. So that was about the tangents. Now the tangents are also going to be useful for you, because you may be required to find out the length of certain things. So for example, if this is the tangent over here, you just join this part over here, and you know that you can use Pythagoras theorem. So if you know that this distance over here, if this distance is known to you and this distance is known to you, then automatically you can find out the radius by Pythagoras theorem, because it's a right angle triangle. So this square minus this square will be this square. So that is also a kind of questions which are going to be there in your exercise. So yeah, the tangents help you in that way, that you can get a right angle triangle over there, so that you can use Pythagoras theorem a little. We see the next part of the things. There are the arcs. So the next thing what we are going to have is arc. So the next over here is, if I got a circle here, now if I take any 2 points on the circumference of the circle, that is point A and point B over here, this AB over here is called as the arc. Okay, this AB over here is called as the arc. And if this arc is such that it is formed by the diameter, so if this is the diameter P and Q, then this particular arc complete over here, this arc will be called as semicircle. Okay, so first thing is that PQ arc is going to form semicircle. AB arc is going to form an arc. Okay, this is an arc. AB is an arc, whereas this PQ is the semicircle. Of course, the complete thing is called as the circumference of the circle. So the complete circle, so complete circle is the circumference. So when you are talking about the length of the circle, so we say this part of the length of the circle will be the arc, the half of the length of the circle will be semicircle, and the full length of the circle will be the circumference of the circle. Whenever you are saying an arc, so when I talk about the arc over here, so if I take an arc AB here, I can actually have two arcs. One arc will be this one, and the other one arc will be this one. So I will name it over here as this is X and this is Y. Then I can say arc AXB, the smaller one, is called as minor arc. And the bigger one, that is arc AYB, that is the bigger one, is called as the major arc. So arc could be either minor, that is the smaller one, or major, which is the bigger one. So smaller one will be called as the minor arc, and the bigger one will be called as the major arc. Now these arcs, what you are going to get, these arcs will also be forming an angle over here. So if this is the center, this arc is going to form an angle over here. This angle what is formed is called as the, so if this angle is theta over here, is called as the angle subtended by the arc. So this theta is equals to angle subtended by the arc. And if the arc is subtending the angle at the center, it is called as the central angle. So if the angle is being subtended, or even if the chord is subtending this angle, if this chord AB is subtending this angle, at the center, then this particular angle which is called formed over here is called as the central angle. Okay, so this was about the arc. The arc forms a minor arc, major arc. Arc also forms an angle at any, it can form angle even over here at the circumference. That's called as the angle subtended by the arc. If it is at the center, then it is called as the central angle. The central angle can be by the arc also or even by the chord also. So that is with the angle subtended by the arc or the angle subtended by the chord. Now this arc also and the central angle over here is going to divide the circle again into two parts. One part will be this area. This area over here is called as that is AXB area. So area AXB is called as minor sector. Okay, this is the minor sector. This is minor sector, and this particular part over here becomes the major sector. Okay, so minor sector and major sector for the angle. And if it is such that a chord is forming that particular area, so if this is the thing and there is a chord over here, then this area over here is called as the minor segment, and this area over here is the major segment. So the chords will give rise to two parts. One chord can give rise to two parts in a particular circle. The smaller part is called as the minor segment and the bigger part is called as the major segment. Whereas if the arc is forming a central angle, the central angle along with the arc will form two parts of the triangle like a pizza ka piece. That is a sector, the minor sector for a smaller one, bigger sector, the major sector. That is about the segments. Now we see a very important property of the triangle of the circle, and that is angle subtended by the diameter. So we can see over here, it's a very interesting kind of a fact that if I draw a circle and to the circle if I draw a diameter, if I draw any angle with this point and the third point being anywhere on the circumference, like it could be this way, then this is definitely going to be 90 degrees. It is angle in a semicircle is equal to 90 degrees. You can try it. You can draw another line from here which could be like this and draw here. You will find that this is 90 degrees. You can draw even like this, something like this, and you draw like this. This again is 90 degrees. You can draw here also. Again this is 90 degrees. You can try it on your own. You can draw a circle, take a diameter, and then you draw all the different lines and take a protractor and find it out. You will find that all of them are 90 degrees. So this becomes a very important property over here, that angles in a semicircle are right angles. Angles in a semicircle is right angle or 90 degree. That becomes a very important feature, a very important kind of a property of circle. So that was about the explanation about this chapter. So we will continue with the exercise 15 in the next video.